Stacy, we will start. Okay, thank you all for being here for another session of the Matrix Fall talks. Today we have John Basl, who is an associate professor of philosophy at Northeastern University and also an associate director of the Northeastern Ethics Institute, where he leads AI and data ethics initiatives. He works broadly in moral philosophy, with a special focus on the ethics of emerging technologies, including AI. So thank you so much for being here, John. And for the people in the audience, please make sure you type your questions while John is presenting. And at the end, you are all going to become panelists, so you can ask your questions directly. Thank you, and looking forward to your talk.
Thank you so much. Thank you all for joining. I can't see you all, but it's nice to be here with you in whatever that's come to mean in today's age. So today, what I'm going to do is try to motivate my work. I work on issues of transparency and sort of deep fundamental ethics issues in AI and machine learning. But what I really wanted to do is motivate the need for what I'm going to call an ethics ecosystem for AI and big data, and talk about what an ethics ecosystem at least partly consists in, and sort of wave my hands in the direction of how we might cultivate such an ecosystem. And I'm going to do this by talking across different areas and examples where we deploy AI and big data. I'm also going to do something that makes me, as a philosopher, very uncomfortable. I'm going to say some things that I won't defend in excruciating, painful detail, but I'm happy to follow up on any arguments or things like that. So I'm going to sketch some arguments that I made elsewhere very rapidly, but I'm happy to come back to them. Okay, so AI holds great promise, as we were discussing before we started. Maybe not as much promise as often appears in the headlines, but it holds great promise across a huge number of domains of application. And there's a large contingent of people that really want to realize that promise in a responsible, ethical way. I really don't doubt that about the practitioners and developers of these tools. Maybe some of them I doubt that about, but not most of them. But right now, that's not what's happening. Despite many actors having good intentions and despite resources being increasingly allocated towards ethical AI, we're not there. What we want is to realize the promise of AI while mitigating against ethical pitfalls and wrongdoing. But what we have is an unstructured mess of concepts, commitments to broad values without any guidance about how to realize those values in practice. We have a bunch of different languages that we're all speaking to one another. Explainable AI, fair AI, responsible AI, trustworthy AI that everyone uses differently and fights over without any common sort of terminology or even ensuring that we're all saying the same things. And that's an optimistic picture, I think, of where we are. I could have, for example, chosen to paste a pile of news headlines from the past 6 months or year about the ways in which we're failing to realize the aim of ethical AI. And even scarier, I could have probably used headlines from 2 years ago and match them up with headlines that are 6 months old, and you'd see recurring problems in those headlines, despite the difference in time. Now, in my view, one of the reasons we're in the state that we're in is that we lack what I'm going to call an ethics ecosystem for this domain of technologies. And to motivate that, I'm going to highlight some problems and mistakes that we keep making in the development and deployment and oversight of AI. So we face a variety of problems, and it's not just that companies or individuals just keep doing ethically suspect things. That happens, but that's not the main issue. The problem is systemic. We keep hitting walls even among the actors trying to do the right thing. And I want to discuss 3 types of problems or mistakes that are sort of the obstacles that are across the domain. And I'll give some examples of each as we go ahead. So first, at various levels of decision making, from individuals to organizations to leadership to governance spaces, we lack concrete operationalized guidance or evaluation tools. And because of that, we've tended to grab onto existing tools from other contexts, but they're not that useful in the context of AI and big data. Like AI and big data transform or change in important ways the kinds of tools that would actually help us achieve the things we want to achieve. And I'm going to talk about that using privacy and informed consent. We'll get to that in a minute. Where there has been genuine movement to develop actionable guidance or context-sensitive tools and approaches, the recommendations are often bad. And there's 2 reasons that this has been so. One is that for many of those with expertise in ethics, like myself, especially in my discipline, unfortunately, we have failed to appreciate how ethical frameworks and tools interact with the actual details of the technologies that we hope to provide guidance for. So we offer very flip or fragile guidance that's just insensitive to the way these tools work, and so it ends up being bad advice. And I'm going to give that example by talking about autonomous vehicles. And then there's another reason, and that's that it's not all philosophers' fault. I'll shoulder some of the blame, but it's partly everybody else's fault. There are many interested in solving these problems, and they have lots of technical proficiency, but they don't understand ethics in any deep way, and they don't understand disciplines related to ethics in a deep way, or how to move from value commitments to technological solutions. And as it happens, given their technical expertise, they tend to focus on technical solutions in spaces where they can exercise that expertise. So it's in some sense not surprising what their focus ends up being. But it does lead to problems. It does sort of misidentify the intervention space and where we should be thinking about how to deploy ethics. And to illustrate that example, I'm going to talk a bit about algorithmic fairness and opacity. But these are all just examples. I could have substituted in lots of different things. So let me talk about misapplying existing ethical tools. And to do so, I'm going to talk about the ways in which informed consent and anonymization get applied in the context of big data and why they just don't cut it. So informed consent and anonymization of personal identifiers are not foundational tools. They're not foundational values. They're tools. They're tools that we developed as a means to protect or promote certain values. So these tools arose in a biomedical clinical research context. And they're operationalizations of norms that are meant to be responsive to foundational values. So on a standard picture, they are tools ultimately meant to show respect for persons because at the intermediate level, they promote and protect autonomy. So as tools, informed consent and anonymization of personal identifiers work pretty well in the context in which they were developed. It is the case that by ensuring that people in clinical research or biomedical research give informed consent under the conditions in which they do so, you are respecting their autonomy. Of course, we can do well or poorly, but it seems to realize that value, and that's part of showing respect to that person. And the same for anonymization. In traditional healthcare context, keeping traditional identifiers anonymous, like birth date, social security number, does tend to protect the privacy of the patient, which increases their autonomy and their well-being. But in the case of big data analytics, the practical tools have been treated as off-the-shelf solutions. In traditional biomedical research, it makes sense to orient practical tools around primary research subjects about the people you're doing the research on. And anonymization, like I said, will tend to protect those individuals' privacy in ways that serve their autonomy and well-being. But a couple things to say about this. Informed consent works in part because informed consent is actually embedded in a broader ethics ecosystem itself, where the consent procedure is evaluated by an ROB to ensure that a bunch of sub-obligations to disclose, to meet obligations of disclosure, informedness, and non-coercion have been met. But in the big data analytics context, they've been applied in very different ways. So drawing on some work from Helen Nissenbaum and Solon Barikos, like one thing that's happened is informed consent, where it's in bioethics, is sort of subject to this oversight constraint that makes sure those obligations are met. The way it's been transformed in the case of big data analytics, where you actually could not plausibly get informed consent from every individual, like if you had to sit down with them and talk through whatever you're doing. So we have notice and consent. So instead, we just provide a massive document that's almost entirely in legalese, and we get a token of consent. They click agree. You don't have that. So there's no ensuring that the information is disclosed in a way that's comprehensible like it would be in an informed consent context. So the tool has not only been taken off the shelf, but it's been transformed in a way to fit this context in a way that sort of doesn't align with the values we care about. But even where we do follow the letter and spirit of the tools, for example, not collecting or using so-called personal identifiers, these tools fall short of protecting core values in this new context. So in the case of big data analytics, we don't need access to personal identifiers in order to reliably track and make inferences about others. Furthermore, even assuming I get appropriate consent from some individuals and in ways that makes privacy intrusion permissible, their data allows me to make potentially invasive inferences, for example, about sexual preference or pregnancy status, about others that have not consented to such data collection. And so we take this tool that's really built for a context where by protecting the sort of research subject, we actually protect all the relevant stakeholders, or mostly. There's of course exceptions. But now we're using that tool in a case where actually the way the tool works is that it imperils inference subjects, not just data contributors. Finally, many of the autonomy challenges raised by AI and big data analytics are social. They're not oriented towards individual contributors or inference subjects at all. think targeted ads in the way they can influence elections, or distributing resources via algorithms in ways that can limit upward mobility of certain groups that already face historical obstacles to upward mobility. Informed consent and anonymization aren't sufficient tools to promote autonomy, given the kinds of autonomy challenges raised by these technologies. So one challenge we face is just that the ethical tools we've built up to address issues in other contexts are failing us in the context of AI and big data analytics. And in trying to develop new resources, guidance, and ethical tools that we run into, then we hit the other problems that I outlined before, which is philosophers or ethicists, people with ethics background giving bad advice because they don't understand the technology, and the technologist not understanding ethics and so sort of engaging in the wrong kind of intervention. So let me talk briefly about the ways in which those with expertise in ethics have gone astray in attempts to develop resources for addressing the challenges raised by big data. So many of you are probably familiar with popular media articles talking about autonomous vehicle accident scenarios and so-called trolley problems. The popular media and many scholars have made much of the seeming similarity between accident scenarios that involve autonomous vehicles and a set of philosophical thought experiments called trolley cases. If you haven't heard of them before, a train is running down the track. There's a person available to pull a switch. If they pull the switch, it will divert from a track where it will run over 5 people to a track where it will run over only 1 person. So that's one version of a trolley case. So this side depicts the Moral Machine experiment, which is an online tool developed by the MIT Media Lab that constructs equivalents of trolley cases using autonomous vehicles and then uses that to elicit people's views about what the car should do in such and such circumstance. It has millions and millions of data points. The results were published in Nature. And it's not just the popular media and engineers that are thinking about the connection between these cases. Philosophers, for the first time since Aristotle, have people asking him what they should do. So it was sort of the use of these tools was sort of an exciting time within philosophy. But the comparison between autonomous vehicles and trolley cases has led to an interesting debate in the literature. On the one side of the debate are what I'm going to call trolley optimists. They think that the similarity between accident scenarios and trolley cases is not merely superficial. They don't just look alike. Their similarity allows us to rely on our judgments about trolley cases or the resources we use to solve trolley cases to directly inform how we should program autonomous vehicles. Now, some optimists, like those at the Media Lab or some subset of those at the Media Lab that built the Moral Machine, think you should decide by sort of polling the populace and then doing whatever sort of instantiating their values in the vehicles. Others think that we shouldn't rely on surveys of public opinion, but upon expertise. And they want to draw directly on what experts about trolley cases have had to say about them. So that's the survey-based versus expert-based. On the other hand, you have trolley pessimists, and they argue against this use of trolley cases. Now some pessimists are pessimists because they think we shouldn't focus on accident scenarios like these because they're edge cases, and instead let's dedicate our resources to solving problems that are more likely to happen. Others have thought that thought experiments like trolley cases aren't probative. They're not useful because they're very unrealistic. And then there are others that think that actually, despite a surface similarity between accident scenarios and trolley cases, there's important points of disanalogy. There is a lot to say, I think, about this debate. I have a paper on this. But I really think that both sides have it wrong in important ways. The pessimists don't get to simply write off edge cases. They actually need a defense of that. And the quick dismissal of thought experiments on the basis of their unrealism, I think that's a misunderstanding of philosophical methodology. And if you don't like unrealism, have I got news for you about scientific experiments? On the other hand, I think the optimists have it deeply wrong. And that's, I think, because they fail to see how the ethical questions we care about relate to the underlying technologies. So thought experiments can play a role in answering ethically sensitive design questions. And here's how that typically works. You have principles and you have thought experiments, which are carefully designed cases meant to elicit a judgment. You use those cases to sort of test your principles to see if they're broadly applicable or not. And then you try to find the principle that best captures or explains the thought experiments you think are most salient or relevant. Then you can use those principles to answer ethically sensitive design questions. That is totally standard philosophical methodology or ethical methodology. The mistake the optimist makes is in identifying what the ethically sensitive design questions are and how they relate to other questions. They tend to think of AV behaviors and accident scenarios as distinct from the general behavior of autonomous vehicles. But the fundamental systems of AVs rely on machine learning, especially in sort of vision detection systems. And so so what they want to do is take a shortcut from thought experiments to ethically sensitive design questions because of the similarity of the two. But once you recognize how the technology works, you see that you can't skip over the standard philosophical methodology. So here's the question the optimist is trying to answer in the affirmative. Behavior. Should autonomous vehicles be programmed to behave in accident scenarios in ways that conform with the appropriate verdict in similarly structured trolley cases? The optimist answers the question, yes. They say, whether you're survey-based or expert-based, you think that once you construct a trolley case and get the right judgment, you should use that to tell you what you should make a car do in a particular scenario. So that's the question that's how the optimist thinks we should use thought experiments to inform programming autonomous vehicles. But once you know how these things are built, you recognize that there's a bunch of other questions that precede that. So when thinking about programming AVs or training the object recognition systems that AVs rely on, we need to answer a range of questions about how to train these systems. We can ask, for example, how much of our training regime should be oriented towards accident scenarios at all? We can ask, should the accident scenarios we include in the training regime be structured to resemble trolley cases, and which ones? Now notice two things. First, these questions precede the question, how should the car behave in a given scenario? If the answer to the regime question up here is none, then we cut off any discussion of whether the car should behave in any particular way in a particular trolley-like accident scenario. Second, these preceding questions are ethical questions. They're the types of questions to which we need to apply the tools of moral philosophy, the standard picture that I described earlier. Because behaviors in machine learning systems are mediated by the choices we make about a training regime more broadly, and because these choices involve values, it's a mistake to try to move directly from our views about what to do in a discrete trolley case to a view about what to program an autonomous vehicle to do. What we need are principles that provide guidance about training models. And maybe trolley cases or other thought experiments are useful to informing the principles we should deploy when thinking about how to set up training regimes. But it's not because they look like accident scenarios or they determine what a car should do in a particular accident. This failure to take seriously the basics of machine learning shows up in many places in the ethics literature, and we end up dedicating resources to the wrong problem. Even worse, by failing to apply the tools to the right questions, we give advice that is actionable but misleading. If ethicists come and tell engineers, the thing that matters most is that you get these trolley-like accident scenarios correct, they could think about how to construct a training regime to do so. But the ethicists are only offering that advice because they fail to understand the problem. Just as there's ethicists that are insufficiently attentive to the technologies over which they apply their tools, there are technologists that are insufficiently attentive to the foundations of ethics. And I think we can see this both in the development of tools to address issues of algorithmic fairness and interpretability or transparency or whatever your favorite way of describing explainable AI is. So just as a summary of these issues, so one of the challenges we face in leveraging algorithms in decision making is that they inherit the biases of the training data. And indeed, we see many examples of this. Perhaps the most famous or most common, though I think things are a bit more nuanced than the broad discussions of this case, is Compass, which is an algorithm built by a company called Northpoint that does risk evaluation for individuals that are awaiting pretrial detention. It was found to mistakenly label Black defendants as high risk for reoffense at a higher rate than white defendants. Another example, Amazon not that long ago had to shelve an algorithmic tool they were using in hiring once it was discovered that it was discriminating against women. The problem of algorithmic fairness is especially worrisome, perhaps, because people read the outcomes of these systems. By people, I mean not computer scientists, people that rely on the decision-making systems. They read the outcomes as objective because they're based in an algorithm, and then they tend to just defer to them. Second, it can be hard to tell whether the system is being unfair because they rely on proxies for things that we think are normatively ruled out from decision making, but you can't tell that they're actually relying on proxies for race or gender. So one response to the problem of algorithmic fairness has been to develop what we call fairness metrics. These are tools that we can use to ensure a model meets some operationalization of fairness. For example, tweaking things though that the false positive rates are equal across racial groups. Or we can at least use fairness metrics to assess whether an algorithm meets some standard set by that metric to make sure that so we can just identify when error rates are out of whack or something across racial groups or gender or sex or whatever. With respect to the problem of algorithmic opacity or transparency, some tools, as many of you know, are opaque in the sense that even the people that build them are not really in a position to understand why they generate the output they do. I'll come back to that point in a minute. So for example, an algorithm might be used to decide whether or not someone should be rejected for a loan, or an algorithm generates a medical diagnosis, and why it yields that particular outcome in that particular case is inaccessible. Again, there have been a range of responses to this problem. Some have simply objected to the use of uninterpretable models. Others have been working to articulate exactly what standards for interpretability should be. So coming up with like a transparency metric that's like the fairness metric, and then working on technical tools that can extract explanations from models that meet those standards. So now I don't think there's something intrinsically wrong with fairness metrics or tools for increasing interpretability of models, but these approaches to addressing algorithmic fairness and opacity are often myopic, or normatively free-floating. They're disconnected from a careful moral evaluation of what we actually owe to the people over whom we're deciding. There's a tendency to see problems of fairness or opacity as technical problems with a technical solution. And especially for reasons I totally understand for computer scientists, the place in the pathway where you can have some agency and intervene is at the point of roughly building and tweaking a model. Like once it's in the application stage, it's largely out of your hands, and the data collection is often, you'll take what data you can get, because I know it's the resource that's hardest to come by. But so I get why there's the focus there, but there is generally a focus there. But the systems that these are going to get used in aren't purely technical systems, they're socio-technical systems. And the ways in which these technologies interact with values is complex. In the case of fairness metrics are really focused on operationalizing what we call procedural fairness, making sure that a procedure is fair and measuring that by the outcomes of that procedure. But there are other kinds of distributive fairness, and there's also kinds of restitutive fairness, and fairness can be addressed at different points in the pipeline. So as a simple example that shows this, just think about the ways in which fairness evaluations differ depending on the context of application. So Compass, the recidivism prediction tool, it yielded risk scores with differential error rates across different populations. Now, there's, I think, good reason to think that differential error rates are not problematic or a good measure of fairness, but set that aside. On some fairness metrics, that is unfair. But the judgment that it's unfair seems to track that Compass was being used to determine whether individuals should be held for pretrial detention. Like we knew that that was going to come with disproportionate punishment for Black defendants who already faced disproportionate punishment. However, Northpoint, the developer of Compass, says that the tool is not to be used for that. It's to be used to predict when individuals will require greater resource expenditure to prevent reoffense. If the tool were actually used for that, for example, to provide more social services to those with higher risk scores to help prevent reoffense, the fact that it was more likely to judge Black defendants as higher risk would yield higher expenditure of social service resources for individuals that have been historically disadvantaged. And so if we're thinking about fairness from the perspective of restitutive justice, that outcome is not obviously unfair. So there's no evaluating the fairness without thinking about the context of use. Also a side point, like one of my colleagues works on complementarity, and like often we think of trade-offs all happening in the model. So you got to balance accuracy, robustness, fairness, or whatever. But we often think of those as necessary trade-offs happening in model building, when often you could combat them in the application. You could combat, for example, you could make a brittle model part of a system that's extremely robust by doing things on the application side of things rather than the modeling side of things. So you got to have a really broad picture of these systems. In the case of transparency, we see similar kinds of issues. Transparency is not intrinsically valuable, it's instrumentally valuable. We care about being able to explain or understand decisions because it helps us realize some other end. Knowing why I was denied a loan can equip me to make changes that help me secure a loan in the future. It can help me to see that I was treated fairly. It can make me feel respected as an individual. Sometimes the tools we develop to make algorithmic systems interpretable will realize those values, and sometimes not. But we need to really understand the key values rather than just thinking about, well, what are the technical bits that I can make available that will make this interpretable? We have to start with the normative part of what we owe to those we're making decisions about, individuals and social society. And then decide what's the right standard of interpretability. Okay, so that's the quick and dirty overview of some of the mistakes and problems in the space. What lessons should we draw from that? So here are some examples. Here are some lessons you might draw from the case studies I just gave. Everybody should try to understand the technology. Technical solutions can't be normatively free-floating. Keep context in mind. Think socio-technical system instead of simply technical system. Those are totally legitimate lessons to draw, but are not the lessons I want you to draw. It's unreasonable to expect every individual working on these problems to manage the full suite of ethical issues and nuance. Not every humanities faculty can go get a degree in computer science, and vice versa. Instead, I think the lesson is that we need an ethics ecosystem that shapes work in the field in a way that achieves the promise of AI while avoiding the ethical pitfalls. What's an ethics ecosystem? It's very instructive, I think, to compare the landscape for managing ethical issues in the AI space with some other area that has a relatively robust ethics ecosystem, and I'm going to use biomedical ethics. Biomedical ethics has long-standing guidelines for practitioners. Doctors and medical medical researchers receive relatively unified training and rules to follow. They're entrenched, those rules and that training are entrenched in the practice of medicine. There's concrete oversight infrastructure, IRBs. They're often annoying, but and they vary from country to country. It's not always an IRB. They're often annoying, but they are there, and they're sort of in some sense standardized. And that's true for both human and animal subject research. And they work to ensure that there's compliance with specific guidelines and they review research before it starts. There are accountability frameworks. IRBs and other oversight committees have real power to monitor and intervene. We have tools for auditing compliance with the norms. We have regular reviews to ensure, for example, that the ethics infrastructure is living up to its responsibilities, so the IRB itself is subject to review. Bioethics also has a robust research infrastructure. There are conferences to share the work and the latest research. There are robust collections of case studies and training materials. Those conferences question, they have the research resources to question the very foundations of bioethics to try to achieve a stronger foundation for bioethics. Because of all of that, participants in biomedical research and biomedical people in biomedical research and biomedical ethics have a common language that they can speak to each other with. It makes communication easier. There's a common language to advocate and express concerns or justify things to one another. Finally, there is a group of people that are trained intermediaries between ethics and medicine and health research. Bioethicists are not ethicists. They're not philosophical ethicists, and they're not doctors, and they're not lawyers. I mean, they might be one of those things, but they are their own specialty, focused on drawing on and deploying the resources of the field, of the things I just mentioned, to solve ethical challenges and ensure ethical healthcare or ethical biomedical research. Let's contrast that with the state of AI ethics. We don't have specific guidelines for practitioners. There's no concrete or robust oversight infrastructure. Northeast, if you want to talk about this after, Northeastern was just in the news about this recently, and not in the best way. If there was, these things existed, I wouldn't be giving this talk. There are growing research programs and information exchange, but there's still disconnects between key participants in the work. AI ethics specialists and industry partners are not in close contact with one another. We have islands of people working on these issues individually. Technical practitioners and ethical experts don't speak a common language. When I talk about fairness with my colleagues in computer science, and when they talk about fairness with me, we have to spend a ton of time translating what we mean to each other each conversation, because languages are things it's so easy to slip back into the language you were trained in. And so to really get down to business when I'm working with computer scientists, we have to do a bunch of teaching each other the language like we just met each other for the first time. Finally, there's no equivalent to the biomedical ethicist, at least not as a profession. There are a small number of individuals that occupy that sort of role and have the relevant expertise, but not in a way that provides nearly enough capacity to handle all the work that needs to be done. Now, I don't want to overstate things. The systemic capacity in medical ethics or engineering ethics and research ethics and everywhere else isn't perfect. And in the not so distant past, there were significant failures to live up to the standards of ethical medicine and medical research. That's why we have the ethics ecosystems now. And there are many ways that I personally think that all these ethical ecosystems, from law to bioethics to engineering, could improve. The very possibility of change is made possible by the ecosystem itself. It's because there's significant and long-standing research programs and these mechanisms that we can actually reflect backwards on the field and see the ways in which it's failing. Like, a lot of people think that a lot of failures in developing vaccines during the pandemic, or the slowness of developing vaccines, are a function of a failed ethics ecosystem that was not set up to handle the problems of a pandemic well compared to the traditional problems of biomedical research. But things are way worse on the AI ethics side. Even though bioethics, you can complain about the sort of ethics infrastructure for computer science is like YOLO, or dog fooding is about as far as it gets. So what are the components of an ethical ecosystem? Well, one, we need translational research. We need to be able to move from disciplinary insights across a range of disciplines, and to build tools, and to draw on those insights to build tools and apply them to things. We need a translational research program that can identify gaps or problems in disciplinary foundations for further research. Now, notice translational research depends on good foundational research. We actually need to train more people like me, ethicists, to be better about thinking about the ethics of these technologies in a foundational way for there to be something to translate. And that's true, I think, across lots of disciplines. So the translational involves foundational. We need to cultivate interdisciplinary practice. We need to have engagement between social scientists, philosophers, economists, science and technology studies, historians, legal scholars, gender and sexuality and disability study scholars, journalists, media scholars, business people, leaders, key stakeholders, etc., through the life cycle of research, design, development, and deployment of these technologies. So we need to create interdisciplinary practice. We need informed policy and regulation. This is one of the things I'm most skeptical about us getting anytime soon. We need the regulation to be meaningful and sensitive to technology. So for example, the GDPR requires that decision subjects be able to understand the logic of decision systems that make decisions over them. That is not helpful. In the context of ML, that's either trivial to satisfy, like the logic is I used a Bayesian learner and then I gave it this data, or it's impossible to satisfy because you want to understand for a deep neural net like how it came to make the decision it did. So that's not sensitive guidance. We can also talk about the new AI Bill of Rights that came out from the White House, and I think it's not bad, but it's got some things that are, not quite helpful. We also need an ethics infrastructure. We need actionable guidance for institutions and organizations to appropriately incorporate values into technology research, design, development, and deployment. We need things within companies, within academic institutions that help us move from a commitment to broad principles that everyone has to be fair, to be transparent, to maintain privacy, to actual norms that guide specific decisions. And we need an oversight infrastructure. We need to leverage the work that's being done in, for example, algorithmic auditing to create an oversight infrastructure and assessment and accountability tools that can help us minimize ethical failures. We need to organize that instead of having just a loose collection of those things. As part of building an ethics ecosystem, as part of building that infrastructure, we also need to enculturate people into it. If you're an engineer or a doctor or a lawyer, you are provided and you've already internalized an ethics infrastructure. I mean, one of the problems we face is that people are so internalized to their ethics infrastructure that they draw on those tools to solve problems where they're not good tools. But if you're coming from computer science, like I said, it's like move fast and break things is your enculturation, or has been for a long time. There's some resistance to that, of course. We also need, as part of this ecosystem, outreach and education. We need to make understanding of the technology accessible to the public. We need to allow stakeholders to understand ethical values and risk in a more nuanced way. And we need to enable stakeholders to recognize when due care has been taken. Like if you think back to the autonomous vehicle example, not only are the ethicists getting it wrong when they misunderstand the technology, but this is such a popular media thing that I get when I get asked about what I do and I say I do AI ethics, people ask me about the trolley problem. So now it's sort of cemented in people's mind that that's the right way to think about a key ethical issue in autonomous vehicles. But that's because of a failure for us to educate the public on how they should be thinking about this issue. Another good example, I think, is the COVID tracking app that was developed by Google and Apple. It was such an incredible tool and like so privacy sensitive and things like that. But because it was made by Apple and Google and people didn't understand the underlying technologies, it was a total failure. And then one other, like I think at the core of an ethics ecosystem, we need a common language and interdisciplinary practitioners. Not just interdisciplinary engagement, but practitioners that are genuinely working in both disciplines or multiple disciplines. We need to create a generation of AI and data ethicists and a discipline of AI and data ethics, and using that support a common language that enables discourse across people that are in different fields. So not everybody has to be an AI and data ethicist, but if we have that common language and a common practitioner, people can engage with one another, and the AI and data ethicists can translate across different domains. So we essentially need to create a field, AI ethics. Okay, so finally, let's close by talking about how do we get there. And unfortunately, I don't know. This is new territory. I've never created a discipline before. I didn't really want the responsibility or any part of it. I'm a philosopher, and I'm really just comfortable doing the exact kind of things that philosophers do, solving puzzles from an armchair that nobody has to think about or care about. But I know that everybody here has an expertise that's not building this field. And so I think we just all sort of have to say yes and take some responsibility for this and throw a bunch of stuff at the wall to see what sticks. And I'm happy to talk about some of the things we've been doing at Northeastern to build and support such an ecosystem. But I'd like to send the message that we need to take every opportunity to find resources to contribute to the development of this kind of ecosystem. And that means, I think, centering ethics in our grant proposals and research projects rather than sort of, I get invited a lot to NSF proposals where I'm asked to like tack on something on ethics. I'm really happy to be working with Darisha, who brought me on and said, like, tell us what you want to do in ethics, like how does it integrate in the space? And I'm getting more of that from my colleagues at Northeastern, and we really need that meaningful ethics work in proposals that makes space for doing research projects and doing some of this foundational work that will contribute to an ecosystem. What do I mean by sort of centering ethics? Well, you might add educational programming that's oriented towards building interdisciplinary expertise, training programs that are not about compliance, but provide some fundamental background in ethics, or help train ethicists to better understand the technologies in the context of your work. So inviting an ethicist into your lab as a postdoc and getting them up to speed on the tech. You might seek funds or possibility of co-teaching an interdisciplinary course. You might secure funding to embed ethics scholars within research teams. You might dedicate some part of your proposals to solving translational research projects in ethics. You might work to set up an ethics advisory committee and task them with thinking about issues not already governed by an IRB. Like if we want to do ethics in a way that's beyond going of what an IRB would make us do, what would that look like, and how would we restrict our research or organize our research? You might advocate in whatever capacity you can to decision makers, deans, provosts, people at the NSF, NIH to make more resources available for this specific kind of problem. In your curricula, you might look to cultivate AI ethics education, including foundations of ML and big data analytics, not just in your CS curriculum, but in health, business, law, and design curriculum. So we do modular ethics education where we bring ethicists and we put them in CS classrooms and they do specific ethic problems related to the content of the course. Like it's deeply tied to the content of the course. It shows them how these ethical issues arise in context. But the decision-making stack and the stakeholder stack for AI and big data analytics goes way beyond computer scientists. So they need not only ethics education about the interaction between AI and ethics in design and health and business, but they also need just fundamental training on AI. So you can contribute to an AI ethics ecosystem by doing AI training for these people, for public policy people, for example. So I can chat more about some of the things we're doing here, but I think I'll close with that and sort of say, just to stick with the ecosystem metaphor, I think we're in a spot where we don't know exactly what to do, but we need to let 1,000 flowers bloom. Thank you.
Thank you, John. I see we have a few questions, and I have a few questions also afterwards. Ricky, do you want to read the question? Do you want to say the question yourself?
Yeah, I'm starting to make them panelists, so they should be coming on board right now.
I'll take the pause to get some water.
Okay, excellent. I can ask the question that Ricky posted, and yeah, if we.
Sorry, can you?
Can you
Ricky.
please ask the question directly?
First of all, this was an amazing talk. I really enjoyed it. So I work for a credit union. I'm a data scientist here, and the things that we're concerned about in this industry is very different than autonomous vehicles. And do you really think that there's an ethical framework that can reasonably be applied to all industries, or do you think it needs to be more specific? Because biomedical is a single industry, right? And so yeah, that's my question.
That's a great question. And the answer is yes and no. But like biomedical, so one thing about biomedical research, it's one industry by name, but actually it covers a huge range of things. And we need to be like, one of the problems with bioethics is that it started out as being about a very narrow kind of clinical research, but then when you start thinking about population ethics, that's what raises some of the challenges for that ecosystem. So I do think there's like ethical framework come in sort of degrees of specificity. So I think there's some broad framework that we can use to inform how we should think about ethical issues in big data analytics and applications of AI based on machine learning and things like that. But then when you want to get to actual operationalized guidance for a credit union context, as opposed to an autonomous vehicle context, yeah, you're going to have to do much different things. So some of the stuff I've worked on is writing a report on if you wanted to build AI ethics oversight, say you wanted to build an AI ethics committee, here are the kinds of questions you would have to ask that are sensitive to the details of your context to build an oversight committee that was effective and appropriately staffed. The questions you have to answer are all the same. That will sensitize you to the kinds of things you should be taking into account, but how you answer those questions will differ a lot by context. So I think that there's some broad things we can say about the domain, but yeah, absolutely, there's going to be context-specific components. And that's true for even specific values like transparency. Like, I'm sure you care about transparency a fair bit, but what transparency means for you in credit versus medical diagnostics, where you're not even thinking about a patient, you want to understand like what's going on when a diagnosis happens. That's why you care about interpretability. That you're going to want radically different things.
Thank you.
Cheers.
Thank you. We have another question from Mark. Mark, do you want to ask it directly or do you want me to read it? I will read it. So he was agreeing at the time where you were giving the talk. And he was mentioning the biomedical ethics system that he's also working on, I believe, did not arise from systematic application of values, but rather from horrendous failures of traditional research practice. Is that what it takes to effect change? Is his question.
I love this question. So yeah, what happened is we committed in both the animal subjects oversight and human subject oversight, there were just gross misconduct that then caused the government to say, hey, get your shit together. And then we started doing this process of what values do we care about and how do we translate to actual tools. And then there's this important question of like, is that what's going to happen in this case in order to motivate it? And I hope not. And here's why I hope not. One, I'm not sure that we'll be able to like, it's so easy to recognize the horrendousness of sort of, for example, kidnapping dogs for animal experimentation, which is what led to the Animal Welfare Act. The costs are so much harder to understand in the case here. Like, we've already had massive disruptions to democracy and we didn't get the regulations to demand an ethics ecosystem. So that's why I hope that we don't have to wait for that, because I don't know how bad it's going to have to be before we'll be motivated to do something. But here's why I have some hope that we can do so. There are instances where we built ethics ecosystems that weren't motivated by this, and the only but good example I can give is embryonic stem cell research oversight. That came about during the Bush presidency. They basically said, we're not going to develop an ethics ecosystem for this because we're just not going to fund any research using embryonic stem cells. And so a bunch of institutions started working together to come up with guidelines to how to provide oversight for human embryonic stem cell research that was totally unmotivated by government regulation and is now the industry standard for evaluating that kind of research. So that gives me that it's possible that we could pull ourselves together and do this even if the government won't provide us sufficient guidance.
Excellent, thank you. There was another comment. Stephanie was just mentioning that AI is here to help us build services that give automation smartness and enable us to make decisions in a better way, as long as they are doing it in an ethical fashion, right? Another question, how does an autonomous system differ from internal insight ethically? If the goal is to basically emulate human intelligence and action, we accept the ethical agreement of autonomy of thought, albeit actions are questionable. Is the issue more so action versus inferencing in terms of ethical evaluation in the AI problem space?
I'm not, please feel free to jump on and correct me. This
Yes.
does sound like the kind of question that would have to be some back and forth, but my hunch is this, that like, there's a common, like, we use the words agency and decision-making and action equivocally. So there's a sense in which these systems make inferences and decisions and things like that, but they're not agents. They're not moral agents in the sense that they're the kinds of things we hold responsible. So it's true that we're getting them to mimic human decision-making, but that doesn't mean they're doing human decision-making. And they're systems created by us. So the ethical question for us is, when you're trying to create a thing that's going to mimic human behavior in conditions of uncertainty, how do ethical principles tell you to go about building those kinds of things? And the only difference between this technology and any other is that the way that the way that you train the models is slightly different than the way you build bridges. But we can't be certain that a bridge will hold up, and we have to think, given our conditions of uncertainty, how do we build this kind of thing? We just build it in a radically different kind of way. and our principles should be sensitive to the radically different ways we build these things.
Yeah. Another question from Stephanie. Is it worth it to train a Yolo network to get better accuracy on wearable devices signals? What is your recommendation?
Can you tell me what a YOLO? I was using
Stephanie.
you only live once.
Stephanie, do you want to give more input here?
Yes, it's because I started searching about this this network, Yolo, and I saw that it is huge. It is very, very big. But my question is like, is worth it for you to get a huge network that will give you a better accuracy on wearables or in devices with low hardware? Or
asking a
it's
question
better
about
for me to
trade-offs.
get a smaller one that will give me a good answer, but not necessarily the best one,
Yeah.
and it's
So
faster as
answer
well.
to the question is undefined. It's like you can't answer it outside of the context. So like the same, like, is differential privacy a useful tool for protecting privacy? There's not an answer to that question. It's, is it useful in this particular use case, given the kinds of data and given the ways we're using it? So like should we trade off accuracy for robustness? It totally depends. Sometimes accuracy matters a lot more than, and we're willing to trade a lot of brittleness in the cases where it's brittle for the accuracy we get where it's not. And this is what, like, there's socio-technical systems. We really have to think carefully about each use case, which is what makes this infuriating, because I know that what computer science, I still get asked, it happens less and less, tell me what the true fairness metric is. And then my kettle boils a little, and then we have a little chat. But so I don't, it's hard to say. Like, I'd have to hear a lot more about the context in which this model's deployed. How does it implicate people's individual data? What are we doing to protect that data on the side? So I think it's hard to answer outside of a lot more context.
And another thing is that, like, for us to get a better accuracy, we will need to get more data. And getting more data, until when are we being ethical to the patient that we are getting that medical
Yeah.
no.
Yeah, that's a great. I think there's really a ton of interesting work to be done on ethical data. How do you get data ethically? Like, how do we use old data in ways that's more ethical, and how do we get new data in more ethical ways? So I have a colleague who works on evaluating the labeling of data, because, for example, medical data that comes from women is labeled differently than medical data that comes from men. How do we evaluate the bias in labeling so we can cut off getting certain data into the data stream in the first place? I think I don't have answers to those questions, but I think it's super important and fascinating.
Yeah,
Thank you so
I'll
much.
come back to the data question a little bit later, but we have a few more questions here. Aura is asking, is there a trust factor that you would implement? Historically, we trusted humans that studied this field. Hopefully they know what they are talking about. But now we are transitioning to decisions derived from AI. How can we give more confidence to these results?
That's a great question. Again, I think it's context sensitive. What it's going to take to get a doctor to trust the diagnostic system is going to mean providing them very different information about how that system works than a patient. And so we have to set so like I'm working on a big project on trust right now, and trust has two components. One is what will make people trust the system, and then when is a system worthy of trust? I mostly think about like what makes a system worthy of trust. Like we can trick people into giving people systems trust, but what makes it worthy of trust? But those come in balance, because it may be the thing that makes it worthy of trust makes it so people trust it less because it's harder to understand or it's not as simply presented. So I think that that's a hard question, and partly it involves empirical work from the social scientists and from other people that can tell us, hey, if you do things this way, people are more likely to pay attention to it. Or the way some of my colleagues think about transparency is it's providing information in a way that lets people critically engage rather than just blindingly accept the outcomes of the system. So how do we design a system, an interface that makes people, why did you come up with that, in a way that when they question it and find their answers, then they're more trusting of the answer they come to.
Interesting. Thank you. Sean is asking a question. He is thanking for a wonderful talk. Often technologies and scientific efforts are agnostic to real-world application. How should researchers who work further upstream from applications, meaning material scientists, consider the ethical impact of their work? Should we try to anticipate those downstream effects, or should we absolve ourselves of the ethical responsibility? Likely not.
Yeah. Well, you guessed the answer to the second part. So I think that's a very hard question. And sometimes I lead corporate trainings for the research divisions of major corporations where they're thinking about exactly, they're like, we're working on the foundational technologies and we have no idea what's going to happen upstream. But it's not quite true that you have no idea what's going to happen upstream. The choices you make determine what the people upstream will even see as a technical possibility. So there are choices you can make that limit the ways they can deploy things. So thinking about downstream in your, recognizing when your technical design decisions have value components and how the choices you make are going to shape the choices of the people further downstream or upstream. I can never remember which direction is more applied. Actually, I do think matters. And so you can't, the further you are away, I think the less responsible you might end up being when there's a misuse of your technology. But there are steps you can take. It's hard to see what they are absent an ethics infrastructure that helps you sort of recognize how to even ask those questions. How do I draw on the relevant expertise? Is there anybody that's going to come check on me to make sure I'm doing things correctly? So it's very hard to evaluate what you should be doing in the absence of the thing that I've been trying to argue for.
Yeah. Okay, Mark also said that this is a terrific talk and an eye-opening talk. One other question that there is a subtle thing that I want to confirm with you. So in general, we say that the AI is not ethical. I want to say that it's not the AI itself, right? It's an algorithm. And if it doesn't have rules or things that that bring a human, a human bias into them, the AI itself will rely on the data that is biased. So is it fair to say that when we talk about AI, it's the data in reality that is tainting the model? It's not necessarily the model itself being unethical, but it's the data that is unethical. And we've seen that all, I mean, history, we never learn from history in this life. I don't know why.
Yeah.
Right? The data that we are using is the one that is unethical. The data that we are using is the one that captures the bias that kept propagating throughout times across different populations and so forth. So do you agree with me that there is a subtle difference when we are talking about learning from data systems? There are systems where you have rules, and that's when the bias can be introduced at the rule level.
Yeah, so I don't think that's quite right. And there's some scholars that work very carefully on this, trying to identify the ways in which each part of the system can be the source of the unethicality. So one thing I could say about the data is like, even though it's accurate, so like it captures our biases, and then you could have used the model in a way that sort of, given those biases, yielded the outcomes we cared about. So thinking about the application context, but also there's stuff that's like, so there's this notion called technical bias. Like you might actually just build a hardware light sensor, which is just worse at detecting darker skin than lighter skin.
Got it. Okay.
Right?
But then it's again a data thing. If you feed only a particular skin color, right? And you have data only for a particular representation of the population,
yeah, but
that's a problem with the data that you are using. Again,
but imagine the way that you're collecting the data is like using a piece of hardware, but you provide equal numbers of, you provide skin tones across the whole spectrum, but the actual hardware itself is just worse at detecting dark skin.
Okay, I see what you mean.
You can get ethical, you can get structural problem, and you could just choose a bad training algorithm for the kind of data you have. So it can be a mismatch between data and algorithm, and not just in the data itself. Just
not in the data. Got it. Yeah. Okay, a few more questions. Sean is saying that thank you so much. This is very timely for me as I'm crafting my dissertation proposal and thinking about its long-term impact. Chris, should software developers build expecting the most malicious use of their design? Oh, okay. So just to rephrase, you know what he means.
That's a great question. One of the modules I teach when I teach corporations is it's on dystopias and utopias. Like describe your technological utopia, describe your technological dystopia, and then notice how little gap there actually is in between them. Like how easy it would be moved. The technology that you use to build the utopia could move you to the dystopia pretty easily. And so I think thinking about worst case scenarios and asking whether you can design away from them is extremely useful. Is it the only tool? Is it always going to be the right way to think about problems? No, but I think we're certainly negligent when we never consider what's the worst possible use of this, and then figure that into our decision making. Yeah. So that's a very good heuristic, I think.
Yeah. Or I love the concept of making an infrastructure as opposed to trusting the individual to be ethical or all knowing of their device and well handling of the data. Biomedical engineers from my background have a limited skill set and they need a better introduction to AI and computer science. That's probably
Fully on
case.
board. Yeah.
Yeah. Okay. Any other questions? You can ask them directly instead of typing them. No other question. You mentioned something about the Google and Apple implementation of the tracking system. Can you say a little bit more about that? Or what was the
So it
what was
was
the issue?
it was Bluetooth. Oh, well, you probably know the technical details better than
I know the technology. I know what they've done technically speaking, but I don't know exactly what you were referring to.
Oh, the public reception was basically nobody would install the app because they thought, given the people that developed the app, they couldn't trust
Oh,
them with
they
the
were
data.
reluctant because
Yeah.
of the
So we
companies.
lost out on this major tool for the pandemic because of people's rightful distrust of the relevant companies. But if they could understand like the actual technologies, they would have been like, whoever built this, we can use it safely. And
Yeah.
so it was,
I installed it within a minute after they released it, by the way.
yeah, me too. I mean, I read the paper and I'm like, this is a technical marvel. I will install this.
Exactly.
Yeah.
Yeah. Okay, I think we have Alec here who wants to ask
Yeah,
Yeah.
one more, I guess. So do you think we can ever fully solve or make significant progress towards the ethical problem of AI without addressing ownership of these systems? Like Google's algorithm does not serve the users. Google's algorithm ultimately is optimized to make the most money for Google. And do you think solving that ownership problem should take higher priority than, or like, do you think that has to come first, or do you think we can make significant strides towards solving the ethical problem without solving that first?
Well, I don't know that I see it as different than part of the ethical problem of just like I don't know what the ownership it is, just like how do we constrain what people are allowed to do with the data they have with respect to the externalities given their goals of maximizing profit. I mean, it's the goal of Ford to make cars that make them money, but we constrain the way they do those things in ways that benefit us and how they're used on the road and things like that. So we can create an infrastructure that controls for against the externalities while maintaining ownership or giving Google, sufficient leeway to use their tools to make some money. But I do think that it's going to be very hard to avoid some of the worst outcomes of the deployment of these technologies with companies constantly personalizing things using big data analytics. There's just an incentive to hoover up as much data as possible and personalize things as much as possible. And that comes with massive costs to information quality and democratic institutions. So solving that is a major part of the problem. Whether we can do anything to stop that without major regulation, I don't know. I worry about that.
Okay, thanks.
Yeah, sure.
You mentioned regulation. I would ask, what do you think? Europe has stricter laws, right? And they had the GDPR. They have significantly stricter regulations and so forth. Where do you think? When do you think we are going to get to the same level? And what are the extra needed type of regulations when we talk about ethics in particular? Europe, I mean, the European Union is touching upon those as well to some extent.
Yeah, so I think there's multiple parts. So like the law is not all of ethics. Like complying with the laws and all there's ethics. So there's going to be a substantial bit of work to do on like what is ethical practice and accountability beyond the law. When will we get regulations? I have no idea. Like it's hard for me to imagine what our political system looks like such that we get meaningful regulation when so many people are captured by lobbyists and when there's so much disagreement between the parties. But maybe, Twitter will piss everyone off enough that they'll start regulating information or something like that. What should the laws look like? So this is the thing, like my expertise is very far from what effective policy and regulation looks like. So I could provide information about what outcomes I'd like to see. Like, here's what I think we owe in terms of fairness and justice or transparency broadly. Now, somebody in policy and regulation is going to have to tell me what kind of tools we can actually build to achieve that. It's so foreign to me.
Got it. Thank you.
Yeah.
Okay, I don't see more questions. Let's give it 3 more seconds. Maybe somebody will jump in on another question. I guess not, but we had a lot of them. Thank
are
you so
great
much,
questions. Thank
Jonah.
you all
This was
so much.
excellent. Thank you so much.
Thank
I
you.
will keep thinking about what you were saying. It's not only in the data. We'll keep thinking from that perspective.
Cheers.
Thank you.
All right, cheers. Bye all. Thank you so much.
Bye.